Hey, pre-calculus students, welcome to semester final exam review for second semester, page 1 only. I'll do this in a series of short videos from each of our, I believe, 10 pages. And one thing to bear in mind on this, your calculator is going to be available. These are going to be multiple choice. We have some different approaches, and I'm going to try to keep this calculator based quite a bit. When they say solve by substitution, guys, you can solve this. You want to RREF this in your calculator. You want to enter this as 326 negative 313 and go to calculator. You may do that. However, this is such an easy elimination, so don't feel bound by those directions. Here we get 3y equals 9. If I add these, the x's cancel. I get y equals 3. If I jump back into the first equation, make that 3x plus 2 times 3 equals 6. Substitute 3 back in for y, and I get 3x equals 6 minus 6, 0. So we get x is 0 and y is 3, and we've got answer B. So I'll use some scratch paper at times when we need some space. But if I can fit it in there, I'm going to fit it on the problem. All right. At each game, a local ballpark earns $2,530. So this is what's coming in. Each ticket costs $8.50. So they're going to get another plus 8.50 times the number of people who come in. But the ballpark has to pay. Here's what we're paying, $4,715 to participating teams and $1,897.50 to the ballpark employees. And each fan of the game is given a free bat, which costs $275 per bat. But if we sell X tickets, there's X of those. How many tickets must the ballpark sell in order to break even? I want my incoming flow of cash to equal my outgoing flow of cash, and we've got this. So from there, guys, this is straight algebra solve for X. And we've got, let's see here, be right with you. So we've got, sorry, I had spilled a drink right there. I'm going to group my X's on one side. I get 8.50x minus 2.75x equals, let's see, I had a 4,715 plus a $1,897.50, and I need to subtract $25, or excuse me, $2,530, and we are just a short skip away from coming up with our correct answer here. I'm going to leave that to the reader. This is Algebra 1 at this point. Okay, solve the system of equations by elimination. If I was going to do that, I might multiply the first equation by 2 to get a 14y and the second equation by negative 17. But here's a good time to RREF one. So let's go ahead and go into our calculator. I'm going to go second matrix. I'm going to edit a new one. It's going to be 2 rows, 3 columns. I want a 13, a 7, a 34, a 9, a 2, a 15. And again, you could have done this for problem number 1 as well. Double check it. Second, quit out of there. Go back into matrix. Math. RREF, row reduced echelon form. Back into matrix. Select matrix A that we just created. And I get 1x equals 1 and 1y equals 3, or 1, 3. All right, here's one we might have looked at in class, but in case you missed it or want to see it again. How much pure water must be mixed with 7 pints of 70% oxalic acid? If I see a percent problem, I'm typically going to set that up as percent of something equals something. In this case, it's percent of this solution. It's 70%. It's not pure oxalic acid, so I'm going to call it a solution. Percent of the solution equals how much acid there is in it. and I note we're going to mix to it. We're going to add to it some water. So let's see, we start with 70%, 0.70 of means times how much solution did we start with? 7 pints. Oftentimes you might have a variable here. It might say what percent, or how much solution did you start with if it was 70% and ended up being 22%. But we don't have a variable, so 0.70 times 7, 4.9. That's how much acid is in the bottle, if you want to say, or is in the barrel, bucket, whatever. Now we're going to add some pure water. So we're going to add to it some water, which should be 0% acid. How much do we add? I don't know. X, but 0% of X is 0. Some of these you would total. How much total acid do we have? 4.9. How much total solution do we have? X plus 7. But I wouldn't add these. This was 70%, and we're diluting it down by 0. What would go here should be something between 0 and 70, but they give us 22%, so this should be 0.22. So I would get, solving that for X, it was 4.9. I need to divide away 0.22 first before I subtract 7. And I go on, let's go 4.9 divided by 0.22 minus 7 is, I'm going to go math, fraction, and if I subtract 15 from that, oops, I didn't mean to subtract 15 like that. If I subtract, try that again, second entry, second entry, second entry. I want to get all the way back to here. And now if I subtract 15 from that, and I go math fraction, I got 15 and 3/11. So there we go, 15 and 3/11. All right, solve the system. I'm going to go ahead and enter this as a matrix. I'm going to solve this system Gauss-Jordan or RREF. Second matrix, edit. This is 3 equations, 3 unknowns. So 3 by 4. My first equation, I got 2, a 7, a 2, and a 5. Second equation, no x's, 2 y's, 2 z's, and a 10. Third equation, no x's, no y's, 1 z, and a 3. And I'm going to second quit. And I'm going to go back to my RREF of matrix A. I probably could have done it. Well, that was pretty quick. And there we go. If you like, you could math fraction it. Let's see. Looks like math fraction might be nice. Math fraction. And we get negative 15 halves, 2, 3. And there it is. And number 6, same. You got a 3 by 4. Use Gauss-Jordan. You do not have to do that by hand. You have your calculator with you at all times. So second matrix, edit my 3 by 4. Negative 3, negative 4, 2, 7. I'm going to check that as I go, and no wonder I checked it. Let's try that again. Negative 3, negative 4, 2, 7. Second equation, 1, negative 3, 4, 5. Third equation, 13, 13, negative 4, negative 23. Give one quick look to it all. And I believe we are in good shape there. Second quit, second enter. And that is that the problem I just did? Nope. Second matrix. Let me go back and look at that. Edit. And I just entered that one in there. One, negative 3. That's matrix A. Second quit. Oh, I did answer fraction. That was silly. I want to go back to... Got it. There we go. Math fraction. And there we have it, but take a look. I've got this 0, 0, 0, 0 in the bottom row. And that means 0x plus 0y plus 0z equals 0. Therefore, there's many answers, and what we do with that is we start by letting z equal a. Now, this first equation is 1x plus 10/13 z 10/13 z equals negative 1/13. And if I treat that like an a, that value, and solve for x, I get x equals negative 1/13 minus 10/13 a. And I'm probably on track right here. There's our negative 10/13 minus 1/13 in the x position, a in the z position. But we'll go ahead and wrap this one up. And then the y equation, this would be 0x's 1y minus 14/13 z, or a as the case may be, equals negative 22/13. So we get y equals negative 22/13 plus 14/13 a. And that is what I refer to as a point generator. If we put in a value for a, we get a point that is on the intersection of those planes. And that is page 1. The beginning of page 2 has another problem like this. We'll have a little bit more work to do on it, but that concludes page 1.